IP layer. So inside this TCP here, this TCP here has like 4 layers. This TCP has 4 layers. The layers is count by from the down to top. So don't do a mistake and counting from top to down. No, layers is from down to top. First layer for a TCP IP is a network access layer. The second layer is a internet layer. Third layer is a transport layer, and the last layer is a application layer. So you need to put that one in mind. The first layer of a TCP IP is a network access layer. Second layer is a internet layer. Third layer is a transport, and the last layer is a application. So let's try to explain what this layer is and how they work when we're talking about networking aspect. So the first layer here is, which is the network access layer, as what I explained to you here. First layer is the network access layer. What's the function of this first layer? Here says TCP IP layers. Network access, TCP IP network access layer combine layer 1 and layer 2 of the OSI model. Before you can understand how this TCP IP works, you need to understand OSI model. Okay, so I'm going to bring out this so that you're going to be using it to understand it. So you're going to see that here we have a TCP IP layers. The first layer of TCP IP is a network layer. Second one is the internet. Third one is a transport, and the last one is the application. So this is what we call OSI layers. So when we get there, I'm going to explain how this OSI works, but just see the layers. The first layer of OSI model is physical layer. Second layer is data link. Third one is network. Next one is transport. Next is a section. Second to the last is presentation. And the last layer of OSI model is application. So this layer here are OSI model layer. So this guy here are OSI model layer. But this layer here are TCP layer. TCP IP layer is the one that has all this layer. Okay, so before we can explain it, I need to bring these two together before you can understand. So here says the network layer of the TCP IP is the combination of layer 1 and layer 2 of OSI model. You're going to see the layer 1 of OSI model is physical and the layer 2 is data link. So if I bring this diagram, the layer 1 of OSI model is physical and the layer 2 is data link. So the combination of these two layers is the one that we have a network access layer. So the function of layer 1 and layer 2 of OSI model, it is what layer 1 does in TCP IP. So what's the function of this layer 1? Here it says this network access layer handle the physical infrastructure that lets computer communicate with one another over the LAN or internet. This cover Ethernet cable, wireless network, network interface card, device driver in your computer, and so on. So this network access layer here is the one that handle the physical infrastructure that lets computer to communicate over the internet or on LAN. How? For example, if I have a two system now and the two system needs to communicate, before a system can communicate, there must be something that we are using to connect them together. Either we are using a cable or we are using wireless. So anytime you are using cable, that cable you are using to connect them together, it falls under what we call network access layer. So the physical infrastructure that allows system to communicate. So for example, another example is this, if I need to send you a message on WhatsApp, before I'm able to send the message on WhatsApp, my phone must be present. And when my phone is present, there must be SIM on my phone before I can be sending the message. All those devices fall inside what we call network access layer, which are the physical devices that allow two devices to communicate on the network. All those devices can be your cable, it can be Cat6, It can be your wireless devices such as your wireless router or wireless access point. It can be your NIC, which is a network interface card and device driver. So all those things here falls inside what we call network access layer. So before anybody can communicate on the network, there must be presence of network access layer. If there is no presence of network access layer, no way anyone can communicate. Okay, so the second layer of TCP IP is a internet layer. So here says the internet layer, also known as network layer in OSI model. So the internet layer of TCP IP is what we know as network layer in OSI model. So it means that the function of a network layer of OSI model, that is what internet layer of TCP IP does. So let's now see how this guy work one by one. So when we're talking about this internet layer, here says the internet layer, also known as network layer in OSI model, control the flow and routing of traffic to ensure that data is sent speedily and accurately. This layer is also responsible for reassembling the data packet at its destination. So like what I explained to you here, I already explained to you that anytime a two system needs to communicate, it is the function of TCP to break down the data into what we call segments. TCP will segment the data into smaller particles. So whenever the data gets to destination, it's the function of TCP to reassemble it back into right order. So when the TCP reassemble it back, which layer is doing all those things? The layer responsible for it is what we call network layer. So network layer going to make sure that anything that you are sending and receiving on the network is moving speedily. So it's not maybe I send you message on WhatsApp now and you are receiving the message in the next 3 days. No. If there's a network layer will make sure that the message I sent in my WhatsApp drop in your WhatsApp immediately, except I don't have a network on my system. So if I don't have a network on my system, that is when the information can delay. But if there's a network on my system, any information I send from my system to the other system going to move in a speedy rate and accurate way. So it's the function of a network layer to make sure that the information moves speedily and accurate, and the network layer will still be the one to reassemble the data back when it gets to the destination. So that's the function of the second layer of TCP IP, which is internet layer, which is also known as a network layer of OSI model. Next thing is to know the third layer, which is transport layer. So here it says the transport layer provide a reliable data connection. Actually, this transport layer here is also known as transport layer on OSI model. So there's no difference between the two guys. The transport layer of TCP is also what we know as transport layer of OSI model. So let's see how this guy works. So the transport layer provides a reliable data connection between the two communicating devices. The transport layer divides the data in packets, acknowledge the packet it has received from the sender, and ensure that the recipient acknowledge the packet it received. So when we're talking about a transport layer is the one that provides a reliable communication in between two devices on the network. How? So for example, if I have, for example, let's assume that I have a system. So I'm going to do it like this. If I have one system here connecting to another system, is the function of a network transport layer to make sure that these two systems, their connection is secure. Is the function of a transport layer to provide a reliable communication in between these guys in a way that anything that system A sent to system B, all those information going to enter successfully. How? I already explained to you that what TCP does is that it's going to break the data into different segments. Like we're going to have different paths. So anytime it's sending it, maybe this segment is like 5 and this guy is sending this 5 to this destination. If this guy send the 5, it is function of a transport layer to ask the receiver, say, hey, do you receive all the packets that I sent to you? So if this receiver now say that I only receive 4 out of 5, so it's the function of a transport layer to send the remaining one so that the data will be completed. So a transport layer bring a reliable communication in between the two guys so that anything the computer A send it to computer B going to get successful to the destination, and no way a bad guy can interact with all those information. So it's the function of transport layer to make sure that any information sending from one end to another move successful. So for example, let me make another example. Let's assume that I need to send you a video inside my phone, and that video contains 5 parts. So once I send a video on my phone and the video gets to your phone, it is function of the transport layers to ask you, hey, do you receive all the video I sent to you? So anytime the receiver said that yes, he received the video, transport layer going to stop. But anytime the receiver said that out of the 5, he only received 4, it is a function of a transport layer to resend the remaining one and make sure that all the information gets completed to the receiver. So that's the function of that transport layer. So the last layer of this OSI, of this TCP IP, is a application layer. Actually, this application layer is a combination of the last 3 layers of a OSI model, which is the combination of the layer 5, layer 6, and layer 7 of OSI model. The layer 5 of OSI model is a session layer. Layer 6 of OSI model is a presentation layer, and the layer 7 of OSI model is the application layer. So it means that the function of these 3 layers of OSI model, that is what the last layer of TCP IP layers does. So let's try to see how it works. So here says TCP IP layers combine layer 5, layer 6, and layer 7 of OSI model. The application layer is the group of applications that let the users access the network. For most of us, that means email. What we use to access mail is when you are using a Gmail or Yahoo Mail application. What about a messaging app like Skype and Zoom, and cloud storage program like Dropbox? This is what the end user sees and interact with when sending and receiving data. So when we're talking about this application layer is now the layer that the users now going to use to have access to the information. For example, now, if I tell you that I sent you a message on WhatsApp and you did not have WhatsApp on your phone, there's no way you're going to see the message, know how you're going to do it. So there must be the application of that WhatsApp before you can receive the message I sent to you. What if I sent you a mail? If you don't have a Gmail, no way you can actually access the message. If you don't have a Yahoo Mail, no way you can actually have access the message. So all those things fall inside the application layer. They allow the users to interact with that particular message. So it means that anytime 2 devices is communicate to one another, they pass through what we call TCP IP. It means that the information first comes from a network access layer, come to internet layer, come to transport layer before it comes to application layer, before the users can now see message. So for example, if I use my WhatsApp to send you a message on your own phone, before you can see the message already passed through this different layer. And anytime anyone out of this layer get issue, no way the user will be able to receive the information. Okay, so before we move on, please, is there any question based on what we explained so far? Any question on the TCP IP? Okay, I'm hearing you.
I would like to know what the full meaning of OSI is.
Open System Interconnection.
All right, thank you very much.
Yeah. Other question, please. If there's no question, that means that you guys understand. So if you have something that's not clear to you, the best thing is to ask question. And we're going to explain more about how. Okay, so I already explained to you TCP/IP has four layers. The first layer is the network access, second is the internet, and the third is transport, and the last is application. And I explained the function of all those layers. So all these layers are the layers that allow two devices to communicate. So anytime devices are communicate on the network, they make use of a TCP/IP layer. And if anyone out of this layer get issues, no way devices can communicate. Okay, so we're through with the TCP/IP. Let's move into the OSI layers. The OSI models layer. As you already know, OSI stands from Open System Interconnection. OSI, Open System Interconnection. What's the function of this OSI? OSI is a reference model developed by ISO. So my question is this: TCP is developed by who? TCP is developed by who?
DOD.
Yeah, TCP is developed by the US DoD, which is the United States Department of Defense. So this OSI here is developed by ISO, which is an international standard organization. So these guys they are the one that develop OSI, and DoDs are the one that develop TCP. So here says OSI is a references model developed by ISO to allow network devices manufactured by different vendors to intercommunicate. So let me explain the function of this OSI model. In years back, when we don't have OSI model, what is the problem? The problem is that anytime you see a devices, anytime you see a network, a network devices that is manufactured by different vendors, no way they can communicate. If you see network devices manufactured by different vendors, they are not going to be able to communicate. How? For example, if you have computer A and we have computer B, if this guy here is made by Mac, let's assume that this system here is made by Mac and this system here is made by Windows. If this guy is made by Windows and Mac are different. It means that no way they will be able to communicate. So anytime we have a computer that is made by different vendors, they cannot communicate. So what's now the function of this OSI model? They develop OSI model so that any system that is created from different vendors, they will be able to communicate. So that's the function of OSI model. It means that the OSI model now going to be coming inside the two communication and is going to be acting as an interpreter. So anytime Windows need to communicate to Mac, OSI model will be the ones to translate this window into Mac language before Mac can understand. What if Mac needs to communicate to Windows? OSI model will be the ones to translate the Mac language into Windows language so that Windows will be able to understand. So with the help of OSI model, systems made from different vendors are now able to communicate. But before, when we don't have OSI model, no way devices from different vendors can communicate. Okay, so here says before the OSI model, there was vendor lock-in, like what I explained to you, vendor lock-in in a way that only devices in the same vendors can communicate. So this OSI model we are talking about has 7 layers, number from bottom to top. So those are the layers of this OSI model, like what I bring out here. These are the layers of this OSI model. First layer of OSI model is a physical layer. Second one is data link. Third one is network. Fourth one is transport. Section down to application. So this guy has a 7 layers, which are all what that you see here. This layer here is number from down to top. So someone can ask you, what is the first layer of OSI model? You shouldn't be saying the first layer is application. No. The first layer of OSI model is physical layer. Okay, I'm hearing you.
So the 7 layers on the notepad, why did you not group them? You group some into sections.
Let me go back there. Do you mean this?
Yes,
Do you
data
mean all
link.
do you mean all these things?
Yes.
Yeah, that time when I'm explaining TCP IP, I tell you that there are some layers in OSI model that they combines together to give us TCP IP. So that's the reason why I group them to use that one to explain to you. The first layer of TCP IP is the combination of layer 1 and layer 2 of OSI model. The third layer of OSI model is still the second layer of TCP IP. The fourth layer of OSI model is the third layer of TCP IP, and the last layer of TCP IP is the combination of layer 5, layer 6, and layer 7 of OSI model. So that's the reason why you see it like this. Is it clear, please, or you still have issue with it? Is it clear? Okay, so
My network.
we have 7 layers of this particular OSI model. Start from down to top. So anytime someone asks you what is the first layer of OSI model, put it in mind that the first layer is a physical layer, because before we can have any communication or anywhere, there must be presence of a physical layer. So if there's no physical layer, no way you can have a network layer, talk less of you having a presentation layer. So the first layer of OSI model is physical. After data link, network, transport, session, presentation, and application. Actually, we already explained the function of all these layers in TCP IP. So what's the function of a physical layers? Physical layer here focus on a physical structure. It focus on a physical structure that allow devices to communicate on a network. The first layer of OSI model handle the physical infrastructure that allow devices to communicate. Example can be your coax, your coaxial cable. It can be your fiber cable. It can be your wireless devices, your hub, your repeaters. So all those guys here, they fall under a physical layers. All those things, they fall under physical layer. What about the second layer of a OSI model, which is data link? Data link here going to provide end-to-end connection. So you bring end-to-end endpoint connection to allow all each devices to communicate. So we have different devices we use in data link, like Ethernet, PPP, point-to-point protocol, switch, and bridge. All those guys falls under a data link. And what's the name of the data? Any data you are sending in data link, that data is called frames. Any data you are sending on physical link, that data is called bits. So any data in physical link is called bits. Any data in data link is called frame. So the third layer is the network layer. Network layer here is to allow devices to communicate. It's the one that routes a packet from one network to another to allow a devices to be able to communicate to themselves. So what are the protocol we use in network layer? We use IP, we stand from Internet Protocol. We use ICMP, Internet Control Message Protocol. We use IPsec, Internet Protocol Security, and we use IGMP, Internet Group Message Protocol. So all those guys there are the protocols that we use on a network layer. So what's the name called data in a network? The name that we call data in a network is called packet. The name called data in a network is called packets. So the fourth layer of a OSI model is a transport. Transport layer is the one that provides reliable data connection from one end to another. It gives us end-to-end connection. It gives us a reliable connection so that anything sent from computer A, everything will complete on computer B. So what are the protocol we use in a transport layer? We make use of TCP and UDP. So those are the two protocol works in a transport layer. TCP stands from Transmission Control Protocol. UDP stands from User Datagram Protocol. So these two protocols are the one that we use in transport layer. Actually, there's a difference between TCP and UDP. Do we have anyone that can
Sorry to interrupt
give
you.
us
You
the
say
difference
UDP.
between TCP
UDP
and
stands for
UDP?
what?
What do you
Sorry
say?
to interrupt. Sorry to interrupt you. You said UDP stands for what?
User Datagram Protocol.
Thank you.
So can someone help us to differentiate the difference between TCP and UDP? Do you have any knowledge or any idea? Is there any idea what's the difference between TCP and UDP? Because those are the two protocols that we use in transport layer. Okay, so when you're talking about TCP, TCP is a reliable protocol. TCP gives us a reliable communication protocol. It means that anytime you have a two system on the network and you want to make sure that the information that you send from computer A, everything complete in computer B, you are making use of a TCP. TCP provide a reliable communication and it is not fast. TCP is not fast, but it is secure. It means that anything you are doing with TCP, everything it is secure, and the TCP it is not faster. What about UDP? UDP it is not secure, it is not reliable. UDP is unreliable, but is faster. So anytime you are using UDP, everything you do moving faster, but the UDP is not reliable. How? So let me explain how TCP is reliable from UDP. So let's assume that we have a two system. I wish I get a space to okay, let me just use this small space here. If I have one system here connected to the other system and you have a files of 10 gig. These files of 10 gig, can someone explain what TCP is going to do with this file? What TCP is going to do before it send the file? What's going to happen anytime we are using TCP to send a file from one edge to another?
It's going to break the file into smaller
Yes, TCP going
chunks.
to break the file down. It means that we can actually have like 50 MB. Maybe we have 50 MB. We still have 50 MB. We have 50 MB, 50 MB, 50 MB, 50 MB like that. So TCP will break it down. So when TCP break it down, TCP will be sending it one by one. It means that when TCP send everything finish, it's going to ask the destination, say, hey, did you receive everything that I sent to you? Did you receive all the packet I sent to you? So what if the destination now say that he only received like maybe 4 out of 6. Maybe this guy say he only get 4 packets. Function of TCP is to resend the remaining ones so that everything will get completed on the destination. So TCP is very, very reliable in a way that it's going to make sure that everything you send from computer A complete in computer B. But it is not faster. Okay, but when we're talking about UDP, UDP it is not reliable but is faster. It means that if UDP wants to send these files of 10 gigabits, UDP is not going to break it down into packets. Nothing concerns UDP. UDP is to carry this 10 gig and be throwing it to the destination. What if this destination can only take in a file at the rate of 10 MB and this guy sending a file of 10 gigabytes at once? It means that there's a lot of the file that we lost that this destination is not going to see. So there's a lot of this particular file that will be losted and this destination not going to be receiving it. So when UDP send it, it's not going to ask the destination maybe he receive everything. No, UDP is not going to ask that question. UDP own is just to send the information out faster, but it's not going to verify maybe the information gets to the destination. Different from TCP, they are going to still make sure that everything gets to the destination. So that's different between the two guys. TCP is reliable, UDP is not reliable. So which scenario do you use a TCP? So anytime you are downloading something online, for example, if I'm downloading video on Netflix, maybe the video worth 1 GB, and I still want to make sure that everything I'm downloading on the Netflix, everything enter my system. By default, you are using TCP. So which scenario do you use UDP? Anytime you are streaming videos online, you are playing games online that you don't need a reliable connection, you only need internet to be fast. That is where you use UDP. So anytime you are playing online video, you are playing online video, you are playing online games, all those things you are using UDP. But anytime you need a reliable connection, you are using TCP. Okay, so that's version of this transport. The next one is a session layer. What are the protocol? What are the protocol work for session layer? API, socket, and WinSock. How does this section layer works? For example, let's assume that we have a two system that needs to communicate to themselves on a network. If this system here needs to connect to this system B, for the first place that this guy needs to connect, there will be a page. There will be an open page. Now they're going to asking this guy for username and password. When this guy provide the username and password and he connects,
Please, can anybody hear him, or is it from my side?
Can hear him.
Okay. So anytime that we have a two system that wants to communicate on the network, maybe there's a need for this system here to connect to the system B. For the first time that this system A needs to connect to system B, there will be a page asking the system A for username and password. So when the system name provide the right username and password and you click on login, you will be able to connect. The first time that you click on login, the section is open. It means that the section from the computer A to computer B is already open. There is a established of connection. They will be able to do whatever they are doing. But for the time that this guy finish whatever that is doing, that is disconnect, maybe log out or the disconnect, the section is terminate. So that's the function of a section here. Just like you log into Facebook now. Anytime you want to log into Facebook, they go ask you for your username and password. Anytime you click on login, your session has started. So maybe you disconnect, you log out, your session has been terminated. So we have different protocol work inside this session: API, sockets, and WinSock. So the data that we have, the name that we call data in section is what we call segments. I already let you know that the name that we call data in physical is what we call bits. Name that we call data in data link is what we know as frames. Name that we call data in network is what we know as packets. What about name that we call data on transport? Sorry, the name that we call data on transport is what we know as segments. It is transport that we call segments. So the name that we call data in session is still known as data. So don't do a mistake. Physical is for bits, data link is for frame, network is for packet, and transport is for segment. So session is still data. What about presentation? Presentation here going to let you know how the message going to be presented on the destination computer. It's going to let you know how the message going to be present on the destination computer. So for example, if I send you a image, can someone explain how image used to present on someone's system? Image, maybe I sent you an image. How do you going to know that this thing is image? If someone sent you image now, maybe they sent you image, how are you going to know that this thing is image? Based on the way it presents on your system, how are you going to know? Okay, anytime you see a message and you are seeing PNG, JPEG, when you see something like that, you already know that this thing is image. What if I send you something you see MP3, MP4? You already know that is either a video or is either a music. Anytime you see a message, you are seeing APK, you already know that it is application. So all those things here is what is the function of a presentation. Presentation going to describe how the message going to present on the destination devices. So anytime you see a message and you see that message ended at .apk, you already know that that message is a application. If you see a message PNG, JPEG, you already know that this message is actually image, is a picture. So that's the function of a presentation, to know how the message is going to present on the destination devices, and this presentation is still going to be encrypting all those information. So what are the protocol we use under presentation? SSL, SSH, IMAP, FTP, MPG, and JPEG. So all these guys are the different protocols that we use under this particular presentation. So the last layer of this OSI model is a application layer. So application layer is now where the user can be interacting with the message before they will be able to reply to all those messages. So we have different protocol used in application layer: HTTP, HTTPX, FTP, IRC, SSH, and DNS. So these guys here are actually the layers of that particular OSI model. Just like this diagram I bring here. So if you have a sender on the network and we have a receiver on the network, in each both sender and receiver, they have both their own OSI model. So it means that anytime a sender needs to send information to a receiver, the first thing that a sender uses is what we call application layer. After he uses application layer, it's going to send the data to presentation. The data will be sent down to session. The data will be sent back to transport, sent to network, to data link, to physical, before the data sent from physical of the sender to a physical of the receiver. When the data comes to the physical of the receiver, it will come to data link, come to network, come to transport, come to session, come to presentation, and come to application before this receiver can now be seeing the information. So everything that we are doing from here to down here is what you know as a encapsulation. Encapsulation. So everything that you are doing from down to up here is what they know as a decapsulation. Decapsulation. So it means that anytime you are doing this thing from the receiver time, you will be encrypting everything that you are doing. But anytime the receiver tries to be reversing it, it will be decrypting it. Okay, so that's how the OSI model is. Please, any question based on this OSI model? Is there any question? Or there's something that you did not get very well? So if there's no question here, we're going to see the OSI model and the TCP. There's a diagram here show you that the layer 5, layer 6, and layer 7 of OSI model is the one that they combines together to give us the application layer of the TCP IP. You're going to see transport layer is still the same transport layer here, like what I explained to you. Network layer is network layer, and the network access layer of this particular layer 1 of OTCP is a combination of layer 1 and layer 2 of OSI model. So you're going to see network access layer, the internet layer of layer 2 of TCP is what we know as a network of OSI model. So these two guys actually do the same thing on the network. OSI and TCP, they actually do the same thing. But OSI here is just a theory way and TCP is a practical way. So TCP is what we use nowadays. So OSI is not used in practical way. So this guy only used on the theory aspect, but TCP here is what we use in a practical way. So that's everything about the TCP IP and the OSI layers. So put it in mind, TCP IP has 4 layers and OSI model has 7 layers. So there's stuff that you can use to remember this layer easily, because this layer, it is not easier before you can put it off end, but you can use this. You can use this. Please, you can use this thing to remember. Please do not throw socks. Do not throw socks, pizza away. Pizza away. So you can be using this thing to remember all the layers of that OSI model. Please do not throw socks, pizza away. You will be using the first letter. This P here stands from physical, which is physical layer. D here stands from data link layer. N here stands from network layer. T stands from transport layer. S stands from session layer. P stands from presentation layer, and A stands from application layer. So you can actually use these words here, or you sit down and think whatever you can use so that you're going to be using to remember these layers easily. Please do not throw socks, pizza away. You'll be using the first letter inside all those sentences to remember which layer number 1 first, which layer number 2 down to number 7.